Hi, I'm Will from Tested.
I'm Norm from Tested.
Norm, MakerBot Replicator.
The Replicator is finally here.
Yes.
It's so much bigger and more impressive and pre-built than the previous MakerBots.
It's 13 hours easier to assemble by my clock.
All we had to do is open a box
Yeah.
and then fumble over instructions for about 10 minutes.
And level the platform. So that's the big change with the Replicator. It is dramatically easier to get started and get working.
Yes.
You don't have to assemble it by yourself, which like I said, 10, 15, 20 hours, depending on how good you are.
No more of the screws and the nut bolts.
No nut slots.
No nut slots.
No nut slot jokes here. And no hunting for nichrome wire all over San Francisco. Yeah. There's a bunch of other changes as well with the new machine. First off, the electronics that run it are all on one board instead of a series of small boards of different Arduino controllers and things like that.
So in the old MakerBot, the first one, the Cupcake CNC,
yes,
there were like 5 little Arduino boards you had to actually mount to the side.
One for each stepper motor in the machine.
And now it's all in one little motherboard. It's compact and actually hidden underneath the machine.
Yeah, it's up underneath it. They also, instead of using an external power supply, PC power supply, they're using a big power brick. So you don't have to hide that in the machine anywhere either. These are both good things. It makes the wiring a lot easier.
It looks like a real consumer product.
It's still made of wood.
Yeah, well, that's fine. It's part of the aesthetic.
So before we get into the technical details of the machine, let's explain how it works.
Yeah, how does the MakerBot turn nothing into something?
If you've never watched a MakerBot mystery build, the basic process is there's big spools of ABS plastic in the back. They're 1.8 millimeters around. In this one, they were wider before.
And plastic, it comes in different colors, melts at high temperature.
220 degrees Celsius, or a little bit less than that, actually. What happens is the plastic gets fed through here into these motors where there's a little gear system that pushes it out in very small controlled amounts. So then the print head moves on top of the surface at a high speed and lays down tiny little layers of plastic.
Melted plastic,
which cool almost immediately.
Yep.
One layer at a time. It lays down a whole layer, and then it lifts up a fraction of a millimeter, and then it lays down another layer, and then it lifts up a fraction of a millimeter, and on and on and on. Sometimes 400 or 500, 600 layers for a total print, until at the end, you have a 3D object. So it's kind of like an inkjet printer, but instead of only working in a single line, it's 2D and then with a vertical element. Like 2.5D kind of.
Yes. And you can see the build platform on the Replicator is actually bigger than on the previous MakerBots because you can actually make things now that are they say about the size of a loaf of bread.
So there's a few major enhancements. The size of the build platform is one, although I haven't had a whole lot of luck printing really wide stuff. I've had good luck printing small stuff that fits kind of in the center of the build platform. Once you get out on the wings, I've had some problems with warping, which we'll talk about in a minute. So the biggest change is that instead of previously the print heads moved up and down off of the build platform.
That was on the motor.
That was the whole Z-axis would move up and down. Now the build platform itself moves up and down.
What's the advantage of that?
It gives it a little more stability. So there's a little bit less wobble on the Z-axis when you're trying to print things. So basically the join on the layers is a lot cleaner. Which is important because the resolution of the print head is a little bit smaller on this version than the previous version, which means that the lines that are printed are smaller.
Higher resolution.
Higher resolution, which is better quality models. Takes a little more time for the same size thing.
Now, do the motors actually move the same speed, the stepper motors, as the previous MakerBots?
It depends on which motor you're talking about. Some of them are more or less the same. They're all a little bit more fine control over the motors. You can configure all of that stuff yourself. If you want it to move really fast and have lower precision, you can. If you want it to move really slowly and have good precision, you can also do that. So it's kind of up to you when you get into the tweaking details of the software.
Now, the other big change in the MakerBot Replicator is now, instead of having just one print head, there are 2 extruders, potentially. You can buy 2 models.
Yeah, so it's a $250 option to add a second extruder, which means you can do 2 different colors of plastic, you can do 2 different kinds of materials. Right now, the kind of main software used for this is to do 2 different colors of plastic. Like this test cube has black and white plastic in it.
And they'll just take turns, and in the software, it'll know when to use the left extruder, when to use the right extruder?
Yeah, so the way it works is you actually build the black version of the model and the white version of the model separately, and then you combine the G-code together. The G-code is basically just a flat text file that tells the motors in the machine where they should move when from some basic reference.
And I'll let you know if there are overlapping parts, so it won't actually.
No, it doesn't. You have to do that stuff yourself.
Oh, okay.
So you have to actually pay attention to that stuff when you're creating the model. It's a lot more complex to do multiple colors, multiple types of plastic.
Much more impressive.
It is much cooler. This one we had some calibration problems when we were doing the actual print, so it doesn't look as good as it necessarily could. But getting all that stuff working together, and one of the things that I found, even with just a little bit of experience with the two colors of plastic that it comes with, is that the natural color plastic and the black color plastic have slightly different printing properties. So you have to kind of, it's definitely something that requires a little bit more fiddling.
They don't perfectly meld together.
They don't perfectly meld together, and you really have to design the model with that in mind. The real interesting, exciting, super future version of this is to use a water-soluble plastic as a support material for the ABS plastic, and then you can print things that have moving parts and you know, all like pre-assembled machines, like pre-assembled gearboxes, basically, which is crazy, but that's a little ways off, and the software still needs some work before that'll be possible.
So getting to the software, you do have to have a PC or a Mac or Linux computer to download, to process the G code, to download models, and that all just goes on an SD card. Yeah,
so previously you had the option of either plugging the computer directly into the Thing-O-Matic or Cupcake, which is what we did for a long time, or you could buy a $100 add-on that had like controls to center the print head and all that kind of thing.
And a screen.
And had an SD card slot. So you could print directly from an SD card slot.
And that is built directly in right now.
It's built into all of them. There's a 5-way D-pad that lets you control the menus. Basically what you do is you put the G-code file on a SD card. It has to be a sub 2 gig FAT16 formatted SD card right now. So it's kind of hard to find a 1 gig SD card or a 2 gig SD card just to buy, but it comes with one. So then that will hold basically everything you'll ever print on this. The G-code files are very small.
And then with the on-screen display and the controls, you can calibrate, you can do test runs, you can pick your file from that SD card, and you really don't even need the computer at that point once you have the file on the SD card.
Well, you have to make the file, and when you make the file on the computer, it kind of customizes it for the specific machine that you're using to print on. Because the G-code files, while a 3D model is universal, the G-code files are actually tweaked specific for the machine that you're printing on. So if you're printing on this, you have a different G-code file than if you print on a RepRap. And if you dial in the settings on your MakerBot, then you'll have a different file even than somebody else with the same model MakerBot. So when you first turn on the MakerBot, it has a startup script that walks you through the entire process of leveling the build platform. They include a piece of paper that's the right thickness. Basically, all you do is tighten the screws down all the way on these 4 screws on the build platform, 2 in the front and 2 in the back, so that it's very low. Then you unscrew them following instructions on the screen, and theoretically you should end up with a fairly level build platform.
And this is the only calibration setup that you really need to do.
There's another type of calibration which we'll talk about in a sec, but that's the first calibration.
Okay.
I found it to be a little tricky. I had much better luck after watching their YouTube video that showed how to actually do the calibration than just following the instructions on the screen. So I would say watch the videos, read their instruction manual, then do that calibration.
Calibrating a build platform is simpler than putting together an entire MakerBot.
It's definitely easier, but the levelness of this build platform will dramatically affect your results. And that's another one of the big enhancements to this. You can actually adjust the build platform on the fly. Previously, you had to basically disassemble the entire build platform in order to shim it or make it more level. This is just the 4
screws on the bottom.
4 thumb screws with some springs.
How about the extruder? Any calibration extruder?
So yeah, there's calibration with that as well. Because the print heads are not necessarily perfectly aligned, basically what it does is prints a whole bunch of vertical and horizontal stripes, and it tells you to tell it which ones are closer to each other.
Wow. This is like the 3D printing version of the old HP printer of needing to calibrate the scanner and the inkhead.
Yes, pretty much. So let's talk about the software that you use to control this.
Okay.
There's a piece of software you download. It's free. It's called Replicator G. It includes another piece of software called Skyforge, which you never even see. That's just hidden in the background. And these are, I think, Python apps. So they run on Mac, Windows, and Linux. No problem. Basically, you download an executable, run it, and everything's cool. What these apps do is you import a 3D model in any number of supported formats. The main stuff that you can export from 3D Studio Max and SketchUp and all that are all supported.
Or you can download from Thingiverse.
Or you can download a list, thousands and thousands of pre-designed objects from Thingiverse. And what this Skyforge app does is says, okay, you're printing on a MakerBot Replicator. It has 2 print heads. Here's the temperature that it normally operates at. Here's the amount of infill. The amount of infill is the amount of plastic in between the gaps of an object that you want to have. And then it slices the model in a 3D, in vertical slices, and says, okay, move the print head in this specific pattern to make this layer. then go up this much, then do the same thing on the next layer. It seems like a really simple thing to do, but it's crazy complex, and your settings in there will dramatically affect the quality of your print, even more so than even the levelness of the build platform and things like that.
But there are good tutorials online.
No, they're not. It's a real finicky
Trial and
piece
error.
of software. There are some okay tutorials online. It's much easier with this machine because they're factory calibrated to be pretty good. But yeah, Skyforge is not a fantastic piece of software, and there's definitely room for improvement.
So that's the shortcoming right now. The hardware seems like it's at a good place.
The hardware's getting better.
Getting better. Software needs improvement.
Yeah, I mean, the use case for this machine isn't I want to build things and have a way to rapidly prototype machines. You want a CNC mill or a sintering laser printer for that. This is so you can do fast prototypes that may give you an idea of how things are going to work in the real world.
How things are sized.
Yeah. Make widgets. Like if you break the urinal divider at your office, you can print a new one with this. That's
very
pretty useful.
relevant use case.
Yeah, we had a problem with that at the old office. I don't know who did that, but it happened. And you can learn a lot about both CNC and G-code. The G-code stuff transfers directly over to multi-$100,000 CNC mills.
So you're saying overall $2,000, not for everyone yet.
It's a learning tool, and it's a way to do. If you're an industrial designer and you need to be able to see things quickly, it's much less expensive to buy one of these than even to go to someplace like Tech Shop and use their devices over the course of 5 years. And you can print a lot more.
And good for the classroom.
It's great for classrooms. But it's not. If you're expecting to go out and print crazy robots and stuff like that, you can't inject electronics.
Right.
Right. So it's all mechanical parts at this point. And the joins, even though they're much better than they were before, aren't sufficient to do things like hydraulics and things like that, because it's still multiple layers of plastic being smushed onto each other, not a smooth surface.
All right, let's take a look at some of the prints you've made.
Okay, so the first thing it does on every print is this thing. This is called a raft. Basically what it is a grid of plastic that's laid down to be kind of fat, and it helps it balance out any problems with levelness on the platform. It also gives a good surface for the model to adhere to.
Yeah.
Because by default, the platform's not particularly sticky. MakerBot provides a whole bunch of this kind of gold tape. It's called Kapton tape. It was developed for the space program, and it's a really good high temperature tape that provides a nice surface for adhesion.
It gets pretty hot. It gets like 110 degrees.
The build platform gets to be 110 degrees, which helps inhibit warping, but isn't perfect for that. So the first thing it'll do is do this. This takes a couple minutes, and then it prints the object on top of this. So this is one of the test prints I did. It's not complete. We stopped it midway through because we had some warping issues. But this was to show how it works over a large surface area.
Yeah, it gets pretty big. That's a pretty big object, and it can.
Yeah. So see, it lays like that.
Yep.
It sat on top of this particular raft. And yeah, you can see the individual layers on the edges as you go. And if you go up to the edge, you can peel off. Well, if I can find a place where one's loose, you can probably actually peel off the strings of plastic.
Yeah.
So, they come off in single layers. You can calibrate that stuff and work on that in Skyforge to get a better looking print.
And so this is actually a good example of where our build platform isn't perfectly level, where more calibration may be necessary.
It's difficult to say because there's two things that can cause this. One is that the build this is warping. So what happens is as the plastic cools, as it's being laid down, it comes up, it shrinks, and that pulls it up off of the edges of the platform. It can happen because of poor adhesion to the platform. It can happen because of
environmental conditions.
It's cooling too fast.
Yep.
A lot of people put acrylic sides and a lid on their MakerBot to help stop the warping problem.
Yeah.
It can also be because the build platform is warped. I haven't actually gotten out the micrometer to see if it's perfectly level. It kind of looks a little bowed in the middle, but I haven't confirmed that or not. Right. It could just be an optical illusion.
Now, in the case where we printed something that actually came out almost perfectly.
Yeah. So the big advance is tall stuff.
Yes.
Previously, because of the way the build platform, the print head was moving relative to the build platform, doing something that was tall like this was really, really difficult.
Yeah.
I don't want to say impossible, but unless your machine was really perfectly dialed in, eventually it would just kind of skip and it would tip over.
So this is the Washington Monument.
It's the Washington Monument.
And you downloaded this from Thingiverse?
Yeah, exactly. I sized it to fit this particular printer. You can see there's holes in the top for the windows, for the front door.
That is just amazing, how tiny those holes are.
Yeah.
And they're almost perfectly uniform.
And you have a pretty good square edge. There's a couple places, this seam on the front is where the layer transitions happen. So it does a layer and then it skips up a little bit and does another layer, skips up a little bit, does another layer. Another good example of tower that's called towering. When you do a very small, high vertical piece. Yeah. This was last week's MakerBot mystery object. the first one we did with the new machine. And these towers right here, so the way this works is this is the bottom of the model. It lays flat on the surface, goes up one layer at a time. These were all unsupported as they were going up.
Yeah, they weren't connected until the very end.
Until the very end. And then even when it got to the end, you can see there's not a whole lot of sag because the new printhead can go fast enough over the top.
So it's not tilting and knocking over any.
Well, it doesn't tip over, and there's no droopy bits where the plastic hits. I didn't have to come in and trim this at all. This is as it printed.
It's pretty impressive.
So none of this would have been possible on the Thing-O-Matic, and definitely not on the Cupcake.
Yes.
The trick to printing anything on this is, can you find a flat surface that you can then build up from without too much overhang? And if you can do that, then you can print pretty much anything on there. When they add the ability to do support materials in the software, hopefully later this year, early next, that will make even more stuff available to builders. This isn't probably the most economical 3D printer on the market.
The most remarkable thing is what a vast improvement it is over just 2 years ago. 2 years ago from the Cupcake CNC, even from the Thing-O-Matic, this is just that much big of a jump. The innovations they put into the new machine, the fact that it comes pre-assembled, they test it in their facility, we can give this a half recommendation.
The thing you see that's changed is all the places that we had pain points before. The wobbly Z-axis on the Cupcake was fixed on the Thing-O-Matic. The vibration of the printhead on the Thing-O-Matic was fixed on this. They got rid of the automated build platform because it added too much wobble. The belt feeder added too much wobble to the device, especially with the larger platform size. The printheads heat up incredibly fast now. The feed mechanism with the spools on the back to the front doesn't jam up. It doesn't cause feed issues. And it seems like I haven't been able to strip the plastic inside the printhead yet, which previously meant you had to basically field strip the entire printhead and clean it out and then reassemble it.
I think it's fair to say with this MakerBot, you'll spend more time actually making stuff than fixing the MakerBot.
It's still a hobbyist kind of thing. It's still something you're going to tinker with and spend time working on. But it's definitely much more usable than the previous.
You're going to spend more time actually making stuff.
I think that's a pretty fair thing to say. I mean, we've used it for about 2 weeks now. I haven't had any massive failures, especially, like I said, if I stay in the center area of the build platform. Once I get out the edges, things are weird. But I've actually been talking to their support, and they seem very helpful so far. Very cool. We'll figure it out and get the problem solved.
Yeah, it's on sale now. The two-step extruder head one is $2,000.
$2,000.
And
which is the price of a PC like 4 years ago.
Yeah, exactly. And with just one head, can you add on the second head later?
No, yeah, I think you want to get it built in because the way the electronics are bound into the extruder head, the way this is packed is really neat. You actually attach the extruders to the caddy as you go. There's a couple of injection molded plastic pieces for stability here, and then the caddy for that, and I think the back tray for something else. That stuff's all pretty impressive. But yeah, if you're gonna get the two head, you want to get it from the start because it's hard to add on later if they even let that happen as an option. The plastic, we should talk about how much it costs.
Yep.
It comes in, here, I'll get one out. It comes in these 1 kilogram spools. We have so far used a fraction of one of the spools.
Yeah. It actually comes with, if you buy the two-headed one, it comes with 2 spools.
Yeah, it comes with 1 spool per print head that you get. Natural is the default. I think you get a black spool if you get the 2-head. We got a blue. They're about $45 each. You can get PLA, which is a different form of plastic. You can also get a experimental water-soluble plastic.
Yeah.
The PLA has a tendency to clog the print head, so it's for kind of pro users only, and the water-soluble stuff is all super-duper experimental still. But you can get crazy glow-in-the-dark plastic if you want. All sorts of fluorescent colors, glow-in-the-dark, whatever. I think the best use case for this right now is either designers or classrooms.
Yep.
If you want your kids in your classroom to be able to learn how to do 3D printing, this is the best way to do it. It's the easiest to set up. And like I said, it's not necessarily the best, but it's very well established. There's a massive community of people that will help you if you have problems. Their support's pretty good. It's made in America. So yeah, MakerBot Replicator, $2,000. It's out now. I like it. I think it's cool.
We can look forward to more MakerBot mystery builds on tested.com, and we'll be doing more testing with the MakerBot. We'll be printing stuff, complex objects.
Always printing.
Always be printing.
Till next time, I'm Will.
I'm Norm.
See you guys later.
Bye. Tea. Earl Grey. Hot.